Vipul, so I think you can go to the next slide.
Monica, can you change over the slide, please? Yes.
Yeah, sure.
Yeah.
Yeah, okay. I think we'll start then. And hello, good afternoon, and I'm Ichao, and I'm from I-VTech Solutions, and so together with Tech Data and Autodesk, so we hereby jointly present today's webinar for Fusion 360. Go to the next slide, please. So let's do a brief introduction of us. So we are I-VTech Solutions, and we are authorized Autodesk reseller partner, specializing in product design and manufacturing. So our company has over 20 years of experience in providing computer-aided technologies, related software and solutions. We term this CAX for short. So there are a family of technologies like what Autodesk offers: drafting, 3D design, modeling, analysis, and simulation, and together with other related end-to-end solutions and services. The next slide, please. Okay, so what do we offer? So as we say, we provide end-to-end solutions, right? So based on our clients' need and goals, so we break down into three pillars: design, use, and make. So under the design umbrella, we have 3D modeling and drafting. For simulation and analysis, we specialize in simulation for plastic injection molding, computational fluid dynamics, and final element analysis, FEA services. So these are software that performs simulations that reduce your need for actual testing, and you can predict your product's failure in real-world scenarios. So with almost realistic predictions, you can reduce your cost and waste during design and manufacturing. And under Make, we provide CNC post-processing, and a very popular technology these days, we offer 3D printing services. So lastly, under Application, we cover both software and hardware implementations, and we can customize training of your software systems and product, and also we offer product data management solutions. And the next slide, please. So over the years, our clientele have expanded, and we have customers from a wide variety of segments and industries. So I mean, we have government agencies, Institute of Higher Learning, we have research institutes, oil and gas, semicon, electronic, injection molding, and consumer products. So this is where we have been offering value driving and end-to-end solutions services to them. And next, please. This wraps the introduction for us, and you can always visit our company site, and you can email me for more full range of solutions and services. So I think I'll hand over to today's guest speaker, so to cover for the rest of today's webinar. Over to Vipul, please. Thanks.
Thank you, Yi. So, me and Monica. Me and Monica are from the Autodesk team, and I request Monica to start with the introduction on what platform we are presenting you here.
Thank you, Vipul. Good afternoon, everyone, and thank you for your time to attend this webinar. Our today's topic is Fusion 360, and particularly we will be focusing on CAM. But before starting up, I would like to quickly have a look at the factors which are currently influencing the businesses. So with an advent of transient technologies, it is necessary for an organization to adopt latest changes happening in the environment. It can be a startup or a mid-size or a large corporate. In order to sustain in the market, one has to keep themselves up to date. For instance, if we take an example, it can be a work culture happened during COVID. Especially in the developing countries, work from home is a latest new norm to work. Similarly, if we take an example in the industrial design and manufacturing changes, So earlier, artisans used to make handcrafted products, and then they have evolved sketching or 2D drawings to make the products. And further, 3D has been introduced, where an additional Z-axis has been introduced to the drawing. Also, and now the customers are looking for the look and feel of the product, and that's why they're looking for the prototype before actual production happens. So always we need to keep up the pace and be in line to the changes, whatever it is happening in the environment. Obviously, we cannot sideline the competitors here, because competition is everywhere. So from idea generation to product and marketing strategies, competitors are always ready to imitate one's product and services. And thus, it is really important for a business to strategize from each perspective in order to reap profit and outstand themselves in the market. Supply chain volatility is another factor, if I talk about, which impacts business, as it is an unplanned variation of upstream and downstream of material flows, resulting in a mismatch of supply and demand. So failure to adapt to this volatility can lead to demand buying unmet, and unmet translates into the loss of sales and profit. Now, these factors actually help us or help a business to push and always be on their toes to make a smarter product. Now, smarter product can in you know uh, uh, you know uh, can cater into three major categories, if I say, or major concerns which they need to talk about: is an innovative approach, the latest technology, and the process which is adapt to change. Also, the efficient strategies has to made to consider the less operational cost. A company can also adjust their production levels, raw material purchases, transport capacity in order to maximize the profit. So when demand is high, the company can boost their productions, and when it is low, they can scale back. Autodesk always believe in that adaptability, and thus we have introduced uh, 8 years back a robust platform, which is a unified CAD, CAM, CAE, and PCB workspace. It is an integrated tool from your modeling to GNNC code generation to FEA analysis and circuit board designing. Everything is in a single package. Now let's quickly have a look at the top 5 reasons why customers are spellbounded by this robust platform. The very first is the cloud connect. Obviously, in order to pace up the changes and utilization of resources effectively in workstation, we have introduced very first platform to be cloud connected, where your data, your files can be stored over cloud without thinking that, okay, you require an additional hard drive to store your data or drawings. As I said, that it is an integrated platform of your CAD, CAM, CAE, PCB, all in one tool. So you don't have to break your head, okay, I will be requiring an additional software for my CAM workspace or in my CAD workspace or my PCB circuit board designing. Everything is collaborated and into one. We have designed Fusion 360 in such a way that even a novice user can learn it very quickly. It is a user-friendly software, and thus it is easy to learn. We have So Fusion 360 software comes with a self-paced learning portal where you will find each and every functionality, videos, content available there. We have forums to talk on where the customer engaged day in, day out, what are the challenges they are facing, how they have overcome with Fusion 360. So everything is available there. The data management and collaboration is seamless here, because the stakeholders of different teams, if I talk about design, manufacturing, or other team members, they collaborate in a close mesh and transfer the data in real time. The updation happens in real time. Also, we keep our customers up to date with the latest releases. Usually every 45 days, we come up with update. It may be bugs and fixes, it may be enhancements or any new feature coming up. So we always keep on updating and facilitate our customer with the latest version. So as today's topic is more about manufacturing, so I'll quickly just dive into it. For manufacturing, you can, like these are the quick features which you can have a look into. So we have 2.5, 3, 4, 5 axis milling and turning tool path for positional and simultaneous strategy. Also, we have turning and mill turn tool paths. For sheet metal fabrications, we have water jet, laser, plasma contouring, as well as for metal and plastic printing, we have plastic and metal additive manufacturing as well. So these are a sample list of post processors which are available or which comes with Fusion 360 subscription. So here are the top, it includes all the top brands made by Mazak, made by Mitsubishi, Fanuc Controller, Has Machines. To be precise, we have more than 450 free processors available there, and we keep on updating all these processors. So this is a sample list of to have a look into. Now let's quickly jump to the machining extension. So in order to boost Fusion 360 CAM functionality or unlock the complex strategies of Fusion 360, we have introduced machining extension, which is an additional module which allows you to gain access of complex machining strategies. It simplifies your CAM programming, allowing you to make better use of CNC machine and produce better quality products. It allows you to simplify and speed up drilling process by automatically recognizing holes, selecting tools, and ordering operational for faster CAM programming and shorter cycle times. It also improves your surface finish and machine complex parts safely with automatic collision avoidance. It helps you make rapid edit of toolpaths without wasteful recalculations to start machining sooner and deliver parts faster. So on machine probing is also, we have provided on machining probing to provide or to improve the accuracy of CNC machining. It also has steep and shallow strategy and as well as the part alignment. So these are the couple of features which machining extension offers you. Now I will request Vipul to showcase you the actual product. Over to you, Vipul.
Thank you, Monica. So if you can stop sharing,
Yes.
So hello everyone, I'll be showing you the actual product. So let me know if you can hear me and you can see my screen correctly. Everything okay? Monica, can you see the screen?
Yes,
And
I can see the screen.
okay, awesome. So before we start, one thing, if you have any questions, you can post down in the question and answers or the chat box. I have I-VTech team and Monica on the chat box to answer your questions. And if not, we can take all the question and answers at the end as well. So we will be keeping 5 to 10 minutes at the end for the question and answer session. Right. So starting with Fusion, Monica told you about a lot of features which Fusion has got, and I'm going to show you all those features and how it works in Fusion 360. So this is our Fusion 360 platform, which you can see in my screen. And we have a total of 7 workspaces in Fusion 360, right? So it's not limited to CAD and CAM. We have different rendering and animation workspaces. If you want to quickly test your part before releasing it into the market, we have a simulation workspace and then a drawing workspace to create drawings. But right now, what we'll do is see the manufacturing workspace where we have all the strategies for programming your machines, right? So we have milling, turning, additive, and inspection and fabrication, right? With a combination of milling and turning, I can do turn mill machines as well. So that is very simple. The first thing I would like to show you is how simple it is to start programming in Fusion 360. So I've got a part made and I have bought all this machine table and machine vices from the standard Fusion library. So we have a big library of work holdings and tables as well. And this also we keep on updating it. So I just bought it in, tried to make a setup. Once the setup is done in the uh, design area, what I need to do is I need to define my machine. So I can quickly go define my model, right? Quickly go and define my fixture. So this is the list of things which we have. And then in my stock area, I can define up my raw material as well. So raw material can also be a body or directly from a related size box or cylinder or tube, whichever you want to be, you want to take. And then what I can do is I can use my work coordinate system, define my work coordinate system. So right now I am okay with the z-axis, but I want my x-axis to be along the length of the table. So what I can do is quickly go here, change the x-axis. Now, one thing to notice here is I am directly selecting anywhere. So what is the flexibility of Fusion is it is smart enough to identify and relate things with each other. So I have selected the length of the vice here, and it Fusion is identifying it that if you're defining it in the work setup, the length, then actually what you're doing is defining the x-axis, right? Once this is done, I will go ahead and give it a work offset number. So this is where my definition of the machine in Fusion is complete. Now the next step is to give it some 2D and 3D toolpaths or drilling and multi-axis toolpaths, right? It's very simple. I can start with a basic facing operation. First, first things first, all the operations have the same 5 tabs. To keep it simple, we have kept the same 5 tabs here. The first tab deals with all the tooling options. The tooling options will open up in this library which is called the tool library. And here we have standard Fusion library, which comes with Fusion whenever you install, a local library to install it in your PC, a cloud library if you want to share your libraries with each and everyone in your company, and then the basic libraries of the parts, right? Once I have this open, I do have all the standard shapes of tools available. I just need to select one of it, whichever I want, and then define the size which I need. So let's say if I want to have an end mill, I can go inside an end mill, tell it to be the diameter what I want, the length which what I am keeping and everything. We also have the holder option. Standard holder options are present. Just by double clicking, I can get the holder available. I can store the cutting data here for different materials and how the post processor working this there, right? Once I have the tools defined, I can select it from here, select it like this, and image of the tool will show up. And for roughing operations specifically, Fusion is intelligent enough to actually identify what operations, what cutting parameters will be used. So even if I say okay at this point of time, you will get a very nice toolpath. You can see it's a very nice facing operation which I have got. We have got a simulation to check it. So the simulation is also on the is color aware. So blue color is actually where everything we have some material remaining. Red color is if I have some gouging, and green color if I have the perfect cut done. Right, so you can see the top part is almost reached. Now, the second thing which I want to show you is how easy it is if you want to do a multi-axis programming, right? So with the same facing operation, what I'll do is I'll just go to the second tab in geometry, choose a tool orientation and select, tell it that the Z axis is this one. And you see how it has changed the work plane directly here. With the same settings, nothing to change. I can just say okay. And I have my multi-axis operation right now ready, right? So if I now play the simulation, you will see a first operation which is getting played here, and the second operation which is like this, right? Now, after this, I want to show you special operations which actually is useful in time saving. So a lot of customers has been benefited from this. That is adaptive clearing. Adaptive clearing is the high speed machining technology which we have, and it's included in the base package. There is no extra cost. There is nothing else which is required on this. Right. So first things, I'll select the tool same way. The tooling library is here. I'll just go and select one of the tools in this. Right. And now I'll select the geometry here. So geometry selection is also very easy here. What I can do is I can select it directly from the part. I need to define the tool orientation, obviously, because again, I'm cutting on the sideline. So you see, this is on the part which I can select. Or what I can do is I can use any existing sketches. So what I'm doing here is for the machining boundary, I have created a sketch in the design environment inside Fusion, and I'm selecting that. So now you can see there are actually 3 lines, this one, and this one. What Fusion will be doing is it is intelligent enough to actually understand that I want something between this line and this line and inside this hole. I just need to tell it that I want the tool inside the boundary, no going out of the boundary, please. Right? The heights tab will ask me to the reference, like till which height I want to go. Again, I can define it by the sketch point or even a line or even a plane, whatever I want. Right. The fourth tab deals with the passes. So the optimal load is where actually what is the step over. So optimal load is the step over for it. Now we have one more thing very important in Fusion is this explanation. You see, as I keep my cursor hovering over this optimal load for a few seconds, it is showing you this box in which the explanation comes up. These are called tooltips, and it's very easy when we have tooltips to learn actually. So if I have any doubt on what an option can do, I can just have the tooltip, read it, and then go ahead with it. Right. Once the passes is done, if I want any specific entry points, exit points, lead in, lead out, I can define it in the linking. So here we have the adaptive operation like this. Right. If I go ahead and see the simulation for this, it will be like this. Let me hide the sketching plane and all so that we can see it nicely and play. So what adaptive is actually doing is it is trying to maintain a constant load over the tool. You can see the step over is very much constant. And due to this, there are no jerks coming up in the machine. The loading is very constant and you can use the toolpath in high speeds and feeds, right? When you use it for high speeds and feeds, you obviously are saving time. And yes, many of our customers, we have seen that they have reduced their operation roughing timing from like by 50 to 60%. So they have saved a huge time on this, resulting in profits for them. Like I can speed up the operation and you can see this is how the roughing can be done. To increase your programming time as well, we have certain tools. So one of the tools to increase your programming time is templates. We have templates in which you can create multiple operations together, and that is how actually you can program faster. So here is a contouring template which I use for finishing. I can just use this, tell it the z-axis is this one, something like this. If I want to remove this chain, I can just select it back, not this one, but in this chain, I can just select it back. Okay, ask it to be an open chain and select it somewhere here until here and ask, say, add it. Right, so the selections also are very simple. You don't need to change anything and you can just do it by the way. Right, once this is done, heights are defined, passes are done, I can have the finishing operation like this, a single pass of finishing. Right. Another thing which I would like to show you is our patterning style. So I'll switch on to a file in which I have already created the side toolpaths so that we can save some time here. So there is this adaptive again inside it, another boring operation, a 2D contour to pass on, and a pencil one here. Right. Once this all are done, what I can do is selecting all these operations, I can add it in the pattern. So the same way, if somebody has a design background, you can see we can add patterns here in the manufacturing environment as well. So what happens is if I want to do it on the other side, I can do a patterning around the mid plane and just ask it to preserve the order. And my second side operations are done. Now, if I see the simulation here, it starts like this. A few operations on roughing side, then finishing. And then the tool will take the other side. Right, so it's so easy. Like once you do half of your part, the other half can be done just by using the pattern. Now, once this all things are done, I want to introduce you to some features which are there, in which we can select directly the faces. So if I go here, I'll add one more adaptive operation, which is this one. So we'll take an ended length end mill, select the geometry here. So it's so easy. I can just directly select it from here and then define the machining boundary to be this one. Ask the tool to stay inside every time. Passes are defined. Stock to leave is defined. I want to cut both ways. All the settings can be done here. Okay, I forgot to give bottom reference. So it is telling me and bringing me exact to that location where I have the error. And here is where I have the error and I can go and say, okay. Right. Once this is done, there are various finishing operations which you can use. I like to show you one, which is the flow command. Now, flow command is the command in which we directly do the operation by selecting the faces. So once I select the tool, I can directly select the faces. You can see here like this. And then with this red arrows, the direction is defined. I can come back, define the actual passes. I want 50 passes in between them and say, okay. So you see, this is how the flow toolpath defined. Okay, if I see the flow toolpath now and quickly skip till the end, and then this is how my toolpath will be, right? Another way, actually, the benefit of Fusion 360 is Fusion 360 has an integrated CAD environment. So if you make any changes going back in the CAD geometry, I'm taking the very basic shape here, which was this one. And let's just change this to a little bit more. So 155 degrees. Okay. So if I change this, if the CAD designer needs it to change it to this one, the work which has been done by the CAM guys don't get lost. You don't have to program it again. You don't have to rework it again. You just have to come back, regenerate it all, and everything will be done. Just give it a few seconds. It's regenerating. You can see it also works in parallel processing. So multiple toolpaths are getting generated at once. It depends on the core compatibility of your processor, which is there. And these all operations are already done. There's one adaptive which is taking a little bit of time. It might be because of the step over. Right, let's just wait a few more minutes, a few more seconds before it gets completed. Yes, so it's getting completed. By that time, again, if you have any questions, please write it in the chat box or the question and answer tab which is there, so that we can take it. Right, so now if I check again, everything is all good. And you see, we do have a collision verification kernel which is running behind, and if any collision happens, it will actually tell us, and it will stop at that point of simulation wherever the collision is happening. Right, I can just check it like this. You can see it's all green, so we don't have any gouging, no collisions happening, because the verification is telling us that nothing is there, everything is all good. Right. Now coming to the manufacturing extension part. So for extended use for people who work with complicated designs, we have an machining extension which is there, right? And that machining extension has got several uh, options or properties available into it. Okay, so one property which is there is steep and shallow. So steep and shallow is a very famous strategy for machining continuous steep and shallow areas. If I consider a mold of this type, right, what will happen is in this area where the steep and shallow transition will be happening, usually we get a line of finishing, like a line difference between the steep and shallow area, that is in the finishing time, right? For the same thing, we have developed the steep and shallow operation. So steep and shallow works in the same way. For all the 5 tabs are same. We have a 6th tab which is multi-axis in this, because we can convert the steep and shallow for 5-axis as well. You select a tool, we select a geometry. I can show you the geometry selection is also very easy. You see, I'm just selecting the outer line and the geometry gets selected, right? Heights are again from stock top to model bottom. It's all relative, so we don't bother too much. All the uh, passes, stepping settings can be done here, and all the linking can be done here. Okay, once I say okay, this is how the toolpath will look like. And oops, it didn't generate it. Just let's click once more to generate. Yeah, now it started generating. So this is how steep and shallow looks like, right? If we see it in the simulation, I'll click the simulation and let's skip it till steep and shallow. Right, so this is the roughing part which we have. And if I see the simulation here, okay, this is the starting of steep and shallow. So this is how the complete part is getting done in one go, right? I'd like to just zoom in and show you here. Here is where the transition between steep and shallow is happening. You can see the circular toolpaths, which is here, and then there is this straight line toolpath which is going on. So this is where this overlap is happening, and we are overlapping the toolpath also here just to get you that complete finish between steep and shallow area, right? And even like the non conventional areas like this areas which is like very complicated to do, it's very easy in steep and shallow, right? Now if you might have seen uh, at the start, what happened is there were a certain tool paths which were not needed, and those were this tool paths, right? And this tool paths actually can give you a headache. So in any 3-axis, if you have 3-axis experience, this the finishing tool paths can be very weird sometimes. But we have given a very simple option in our machining extension to actually remove it. What you can do is you can delete the passes of this toolpath directly. So I can just go ahead, select it. This one. Oops. Let me come back. Yeah. This one. So something like this, and I can say, okay, right. And now if you see the toolpath, it's smooth. It doesn't have that extra passes. Okay. Now, this also is parametric. So let's just say that once you have deleted the passes, you want it back. What you can do is here you can see at below it has gotten stored in terms of an operation. What I can do, I can just come back, deselect all and cancel it, or I can just like right click and delete it, and I'll get my passes back. So you don't have to take an effort again and again to do all these things. You can just like go ahead and delete it and change it one by one, right? Another one which we have is if you want to delete a range of toolpaths, what you can do is actually trim it. This works really well. I can just select a boundary like this of any shape and ask it that, okay, I just want to, we just want the toolpaths outside this boundary and say, okay. What it will do is it will delete that and it will give me a toolpath which is joining this. So there are leads and links between this, but it's again very optimized. You can see it's very low and it's just taking a step which is needed. Now coming to the probing section. So once, let's say if this all things are done and I want to check what is the surface finish which I am getting, is it within the tolerance which we expected or not? We have a probing section. Okay, so this probing section has multiple things. One is probing the work coordinate, in which actually you can touch the raw material and probe the work coordinate, probe the geometry. You can check the if the holes, square pockets and all are made within the tolerance or not. And then the most impressive thing is the inspection of surfaces. All things work the same way. So I'd like to show you inspect surfaces for reference. So in inspect surfaces, we select which probe we have, and I can go ahead and select the points where I want to probe, where I want to do the check actually. So I can just probe like this, like this. I can select the points over this and just say okay. Now what it will do is if I take the post out of this, it will give me a post processor. It will give me an NC code, and you can go ahead and check this NC code, take this NC code in the machine and get the result outputs. The result outputs will be in a form of Excel or a CSV document. You can bring it back into Fusion and import that results in Fusion, right? Once it's imported, it will show you a graphical representation of the surface finish which you have achieved, surface inspection which you have achieved. So here is a sample of it. You can see the green ones are within tolerance. The blue ones are above tolerance right now. And we don't have a red one, but if anything goes below tolerance, it will show it in a red color, right? Even the height of this bars will actually show you how much it is within the tolerance or above the tolerance. So for example, this green is having a huge height. So this is on the higher side of the tolerance. It's above tolerance a little bit. But this one is having a lower height. So this is on the below side, on an average side of it. If you see a very tiny green, you know that, okay, like removing even a smallest amount of material in this can bring me below tolerance in this, right? While if it's a big green bar, you can try it, or if you want, you can remove a few more uh, mms from that, right? So this is on the inspection side. One more strategy which we have to increase the productivity is hole recognition. Now, this is a very specific operation or a specific function which we have for anyone who deals with parts which has got many holes, right? So something of this is an engine encasing. So if you are having this kind of parts, then there is a hole recognition in machining extension, which can be really useful. What it does is, once I start the hole recognition, what it will do is it will start identifying all the holes. So it will identify what diameter it has, and if it does need a counter boring or threading or something like that. So I can, then we have standard templates for all the holes, which you can customize as well as per your requirement. And you just have to go ahead and choose which one do you want. So since this is just a straight hole, I just want a simple drill on this. I can say this is a little bit on the bigger end, so I want a spot drill and bore it. On this one, I want to ream it also. There are no thread types, so I cannot see it. This also works on multi-axis. So if I select the multi-axis group, and it will show all the holes which is on the multi-axis side. Right. Once all these settings are done, it's very quick and easy. I can just say OK, and it will give me the drilling operation here. It's taking some time to identify. Let's give it a few more seconds. Yep. So this is here. And you see, these are all the operations which we have in drilling. It has like selected it, done it by itself. There are some places where there are errors. That is just because you don't have a tool for it. So if you don't have a standard tool in your library for this one, it will give you an error that, okay, you need a tool, you need to define a tool. Right. Once all these operations are done, you can select from the 450 plus post processors which Monica mentioned. Every post processor is available for free for use of any Fusion user. So it's useful in many ways. If you have one machine right now and you are planning another machine, you don't need to pay for another, or like in the long run, whenever you buy a machine, you don't need to pay another for another post processor. It's just you can go ahead and use it, right? We have, if you are unable to find it for your own machine, what you can do is you can use the generic controller post. So we have all the controller posts. We have post for Fanuc controllers, which is by the name of Fanuc. We have post for Siemens. Sorry. Siemens controller, which is named by the name Siemens, and all others. So if you want Mitsubishi, Mitsubishi is also there. So each and every post processor will be there. So that is all from my side today. And I'll request Monica to let us like give us a brief on how the users of Fusion 360 have been like successfully implementing this, and what are the benefits that they have got. Over to you, Monica.
Thank you, Vipul. Sure. Let me quickly share the screen. You can see the screen, right?
Yes, we can see it, Monica.
All right. Thank you. Well, I have picked up a couple of customer success stories who have taken a leverage of Fusion 360 with Fusion machining extension and are reaping the profit. Firstly, I would like to talk about Science Van. So this is a family-owned business. They have started up in 1981, where they were providing customers handcrafted signs. But back in 2008, due to stock crunches, similar companies like small and other mid-sized companies, they have also faced a lot of losses. And Jeremy, who is the co-owner of the company, has taken a risk and invested in 5-axis CNC machine. And also was looking for a robust platform that can go hand in hand with the Fusion 360, the CNC machines. So he was planning to have a 3D sculptures, and he was planning to design or sell 3D models of the signs. So he has bought Fusion 360 along with machining extension, and with the very first attempt, he was able to cover up losses of 1 year, which was from 20% to 3%. And also he has reduced the labor cost by 30%. Earlier, how much time, they were taking few weeks to create a sculpture in 3D format, but with the process of Fusion 360 with machining extension, they were able to do it in hours. The best thing which Jeremy liked about Fusion 360 is that you are able to run the simulation programs before you actually cut the material, which is saving the time and making the quality product. So he liked the simulation part the most in Fusion 360. The next is Contour prototyping. So Contour specializes in providing manufacturing services for aerospace, automotive, and medical industry. And they try to build the product and bring it to market in a faster way. So they like the approach, or if I say the combination of the CAD and CAM, because they were able to seamlessly collaborate with the designing and manufacturing team, and also were able to get instant feedbacks with lines and comments on the designs from the customers as well. So they were able to also automate the part setup and program multiple parts per day on their 5-axis CNC machines with Fusion 360 machining extension. Last but not the least, it's Colbert Manufacturing, who were able to save $14,000 by reducing cycle time of 9 minutes with no additional tool wear. So that has a direct impact on bottom line. So that was the words of Daniel Colbert, who was the owner of Colbert Manufacturing. He actually liked the integrated workflow of, again, CAD, CAM, CAE, and PCB platform in a collaborative environment where the machinist used to talk to the designers and instantly get the feedback, and the iterations happen in real time. They were able to access this latest technology and are very happy and reaping the profits very well. So these were the few case studies I have picked up for you. Now we are open for question and answer sessions. Please let us know or write down in the chat box. Team, can we just suggest some time so that they can put the questions?
Yeah. Or I mean, you guys could take it outside of the meeting. You guys have any questions or sales inquiries, you could always reach out to my email, which I'm putting in the chat box again, and on our I-VTech webpage. Okay, another like 2 or 3 minutes. So again, you could look me up if you have any direct messages. You could email me, and if you want to know more about our services, you can look us up at our I-VTech webpage, and there is our contact info also on it. And we are also on social media, LinkedIn and Facebook. If you look up I-VTech Solutions, and we'll also be posting the webinar recordings up there if you would want to view the demo again on another day. Monica, you have anything? I think I sort of wrap up.
No, that's all.
That's all,
That
right?
I have. Yes.
Okay, I guess, yeah, thank you for your support. Thank you, Vipul. Thank you, Monica. Thanks, Charles.
Thank you, everyone.
Thanks, everyone.
Thank you.
Yeah.
Oh, yep.
Thank you.
Yeah, have a
Bye.
good weekend.
Bye.
Okay, bye-bye.
Bye.